So what I was saying is that the first reason for under reinforced design, I just discussed that. The second reason for under reinforced design, going for under reinforced design, is that, just a minute. The second reason was that I discussed about the first reason, which is it will go into that. Just a minute, there are many others joining. So the first reason I've explained to you, that the first reason is that we allow it to go into the ductile zone. The second reason is balanced design does not work always. Why doesn't it work? Because you will never get a section जिसमें आपको you will be able to get the balanced design. Why? Because it will involve compression side में आपको क्या है? You have FCK, B and D. Now FCK has to be clear. If it's 20 megapascals FCK, अगर इसकी M20 strength है, it should be M20. B should be clear that it has got the dimension. D should be clear. Now these two can be maintained, B and D can be maintained, but FCK cannot be maintained in concrete due to workmanship problems. And I've already discussed that agar aap 20 megapascal you are getting for a cube, at the site you may not get 20 megapascals. So thereby this could be almost always less than what is desired. Jitna aapko desired hai, usse kam hi aapko FCK at the site मिलेगा. But FY is not a problem because steel manufacture होता है workshop में, factory में. तो FY would always be perfect. जो आपका testing में result आ गया in the laboratory for FY, you will have the same FY for the steel at the site as well. So if you are designing for a balanced approach, आपने FCK 20 लिया था, but actual में आपको 20 से कम मिला, so your XU will get more, क्योंकि जब ये FCK less than 20 हो जाएगा तो XU आपका बढ़ जाएगा. XU बढ़ने का क्या मतलब है? This over reinforced, going towards over reinforced design. So over reinforced is much more than problematic design approach, and because that leads to much earlier failure of concrete in compression due to brittleness. Clear? Anyone who couldn't understand this second point? Anyone who couldn't understand the second point? I'll again repeat then. So what I just told you, that we have to then go for under reinforced design approach in our design for structures. Now that would mean, what do? We take now under reinforce as the design approach in our design. At most of the times we adopt this. And here now, what is clear, that your XU will be less than XU max. Maximum XU is what? Maximum XU हम उसे कहेंगे is for balance design. Your maximum XU is for balance design. तो यहाँ पर आपको under reinforcement, it is less than XU max. This is less. अगर मैं अब I'll just redraw the same figure जो यहाँ पर बनी है. This is your rectangular beam section, for example. You have this, let this be in black color. So this is your balanced. Then you have the red color now. This is your under reinforce. So this will be now your XU. and your XU max is this. XU max ये है आपका. So XU is for XU max is for balance and XU is for your under reinforced design. So we take XU less than XU max. Now, as per codes, so in this, now for the first time we are using the code IS 456 2000. We'll be using, as per codes, the value of XU max is given to us, but you can calculate this as well. Let's calculate it. XU max का value कितना है? It's 0.87 FYAST by 0.447 FCKB. Now, if I again add D on both sides, now this would be equal to Fy will have a different values. For example, if I take Fy of 500 grade, 500 grade का steel ले रहा हूं मैं, तो its Fy will be 500 megapascals. If Fe 500 अगर मैं ले रहा हूं, तो then it's 500 into, से पहले there is divide, this is 0.447. FCK, for example, you are taking 20 megapascal of strength of concrete, then into में आपको ये आएगा AST by BD. Now, what is AST by BD? What is AST? Any one of you? AST क्या है?
Bar.
So it's the total area of all bars of steel in tensions. AS, A का मतलब है एरिया, S का मतलब है स्टील, T का मतलब है टेंशन में. So tension is on the bottom side. The bars which are in tension, bottom bar steels. So that's AST. तो टेंशन साइड में जितना स्टील है टोटल, उसका क्रॉस सेक्शनल एरिया, ये 2 बार्स है तो इनका टोटल मिला के इनका क्रॉस सेक्शनल एरिया, इसका π/4 d square. D is its diameter of this bar, dia of this bar, और दूसरे बार का ऐसे ही π/4 d square, और दोनों का मिला के you get AST. So the total cross sectional area of these bars. B and D क्या है? What is B and D now? This is your B and D. So you have B and D. D is your effective depth of the bars. So what is B cross D in equal to? B multiplied by D, what will it give? Any one of you? Yes, Sahil is here.
Yes, sir.
What will be B cross D?
So area.
Area of what?
So cross section of concrete. It will be cross section of concrete, area of concrete.
So it will be effective area of concrete. Cover को छोड़ के the other.
क्योंकि हम effective depth ले रहे हैं तो
effective depth ले रहे हैं तो cover छोड़ के, effective cover छोड़ के, rest of the area of concrete. So this is area of steel. In tension, this is area of steel, and this is area of concrete. So area of steel by area of concrete will give you percentage of steel in concrete. Percentage area of steel in concrete. कितना area steel का है within this body of concrete? Total body of concrete में कितना percentage area आपका steel का है? You can get from this, but once you multiply it by 100, then you will get the percentage. Right now, you're just getting the ratio of the area of steel to the ratio of the area of concrete, effective area of concrete. So this AST by BD, now there is minimum amount of steel that we have to always provide in concrete, in minimum in beams, for example, minimum area of steel has to be provided. And the minimum area of steel that we provide is 0.04% of BD. This is the minimum area of steel that we usually provide. So if you now replace this by 0.04, you will get the value of XU max by D for minimum area of steel ke liye. Now, why is there minimum area of steel? I'll come to that once we move into the design of the beams and the other members. So right now, if you now go to the codes have actually mentioned, I'll be sharing with you the codes. You should all have your code in front of you printed even while this class is going on right now. This is the limiting value of XU max by D for FY different grades of steel. They have limiting values. This is based on, again, this is based on the they have actually taken AST by BD as the minimum ratio, and FCK, this is around for 20 megapascal, this is valid. So XU max by D has been taken by the code for different grades of steel. So you have to remember this is XU max by D for 250 grade will be 0.53, for 415 0.48, and for 500 it's 0.46. So these are the values of XU max by D. So you note it down, XU max by D. So thereby your XU, it's 0.5. How much was it? It was 0.546. If it's FE 500. So your XU by D, if it's less than 0.46 for FE 500, वैसे ही for F415 के लिए 0.48 से कम है, then your design is under reinforced design. So this is the concept of under reinforced design approach. Any questions on this? We'll continue further then. So now what is flexural design of concrete members? What is it based on? We'll go step by step. First of all, you have a beam now, and now we know beam has got a width b. It will have a depth overall d, and then it will have steel. You will have steel bars in tension zone. 1, 2, 3. How many? 4 or 5? Any number of steel bars in tension zone. These ones. So then you will have this as effective depth d. Where from till up till which point is the effective depth? Let me show you on larger screen. For example, you have this as the, I'm enlarging this figure. ये concrete है, बाहर वाला section इसका. I'm cutting the section somewhere here. Then this is the bottom portion of the concrete I'm showing you. You have the steel bar somewhere here, one. Similarly, you have another steel bar here. Now, this center line going through this point here decides your effective depth. So effective depth, you always calculate above this line, the center of the bar, D, up till the top of this beam. That's your effective depth. So what is your effective cover now? How much is your effective cover? Yes, any one of you? It is, number one, you are taking the steel bar के नीचे जो भी portion है, that if you resemble that by concrete cover, C, clear cover, CC, and then you have from the bottom up till this red line, that is effective cover. So effective cover CE would be how much? It would be CC. CC इसके नीचे जो है green line के नीचे, and then between these two lines, the red line or green line के बीच में, it is half of the bar dia, steel bar का dia. If the steel bar dia is phi L, if that's phi L, अगर उसका dia phi L है, इसका, if this is phi L, the dia of this, it's phi L, then effective cover will be CC plus half of this dia, that is the radius of this bar. So now you are clear that D is your D, which is the effective depth, is equal to what? It is equal to capital D, which is जो कि overall depth है. This is overall depth minus of CE. And now you all know that what is CE? CE is this, CC plus half times phi. So you can say it's minus CC plus half of phi L. So this is your effective depth, D, from the overall depth. Now, why do we provide cover? The first question about the cover, why do we provide cover for beams? Any one of you? Up till this point, you must have now learned why do we provide cover? Any one of you who wants to answer this? Why do we provide cover for beams?
To prevent corrosion.
Yes, that's one of the reasons. Corrosion prevention. But first reason always would be because we want to embed steel. Embed means where will the steel act together with beam अगर वो steel इसके साथ बंधा नहीं होगा with the concrete. So you cannot tie the steel. आप steel bar को बाहर tie नहीं कर सकते ऐसे beam के साथ at the bottom and then say कि मैं ये tension लेगा. It will not happen. You cannot tie this. So you have to embed it within the concrete. So for embedding, you require certain amount of cover. Now you would say that you could embed it like this. Why to provide anything on इसके नीचे क्यों कुछ देना है? So yes, you can do this. So that's then the first reason to keep the steel within the concrete, you have to embed it. Second reason to shift this, क्योंकि हम इसको अब shift कर रहे हैं, यहाँ बिल्कुल नीचे provide नहीं कर रहे हैं, हम इसको we provide it somewhere after providing the clear cover. तो उसका reason number one is corrosion. This second reason is fire resistance. That's the second reason. Third reason, other than this, is long-term durability, which incorporates many things. We discussed in concrete technology, sulfate attacks happening. In concrete, you have carbonation. So carbonation then leads to corrosion. So before that, the carbonation of concrete would have happened. So you need to provide the cover for many other durability related issues other than corrosion, which is also a durability related issue, but that's a predominant one. Fire resistance, you need to provide the cover. Thirdly, you want the steel to be embedded not only properly, but with proper core within the core of the beam or column or any other element. You want it to be embedded within the core of that, so such that it behaves together with the concrete. अगर एक साइड से इसके concrete ना हुआ, अगर if this was, which I just told you, if this bar was just near, so एक तरफ से ये embedded नहीं होता, then it would not, there would be no bond on this side. So that would mean the bond strength would be lost between the two. They would not behave together. So these are the reasons that we provide cover to any structural elements. We also are providing cover to the beams as well. Next, after cover, now you have for the same beam, next you are providing the steel. Other than steel, you are also providing, I'll make from another, this, you are providing a ring in the beam. और इस रिंग का कुछ अपना diameter होगा. So you would have something like this, a thick thing. This is a ring. तो ये ring है क्या? What is it? It's known as stirrup. For a beam, it's known as stirrups. Stirrup, STIRRUP, stirrup. Now what is a stirrup? What does it do? इस बार का हमें अब मतलब पता चल गई that it's taking tension. Why is this stirrup provided? Why is the ring provided? Any one of you who has a guess? Any guess? Any one of you who can guess? Stirrups are provided to take the shear loads. How do the shear loads act in a beam? आपने पढ़ा होगा in structural analysis, you have a beam and then it's supported on the two ends, one and this is two. At the ends, you have more shear forces towards the supports. You have more shear forces towards the supports. Similarly, and then your bending moment is more at the center rather than at the support. This is your bending moment and this is your shear profile for the beams. Now shear forces, they are more towards the supports. How do the shear forces actually act onto the beam? This is your beam along with its depth. Forces actually, if there is a load acting here, forces travel like this. They have to go towards the support. हर force को it has to travel like ये पानी की तरह flow करता है towards the support. So shear forces are traveling towards the supports. They usually take the center path. ये center. तो जो ये depth है इसकी, they are taking the center path. Most of the forces are going through the center path. So thereby, the maximum shear forces are at the center along the depth of the beam. So the maximum shear force, it's parabolic graph, minimum at the edge and maximum at the center of this, right at the center, not at the neutral axis, but center. Neutral axis is a different thing that's meant for compression, flexural forces. This is shear force. So shear force, under shear force SF, you have the maximum forces acting at the center depth of this beam section. So वो prevent करने के लिए, now how do the shear forces then cause failure? They will cause failure towards the center of this along this central plane, shear plane, and the shear plane would then be the depth of this. But कैसे act करेंगे? At the center of this, it will be acting more. So जो ये screen है, इस screen के बिल्कुल perpendicular the shear forces are flowing. यहाँ पर they are flowing perpendicular. I cannot show you that. अगर मैं पेन लेता हूँ, it could be flowing through the screen at जो मैंने mark किया this point. So how do you prevent that shear failure from happening? You are providing stirrups. तो stirrup क्या करते हैं? They are taking the shear forces along this plane at the center. How? By anchoring the forces towards the top and the bottom. वो forces को distribute कर रहे हैं towards the top and towards the bottom. इसीलिए एक ring की तरह इसको stirrup को दिया जाता है. So they distribute these shear forces towards the top and towards the bottom. Now जब ये ring दिया जाता है in steel, तो end पे उसको tie भी करना है. तो एक end पे एक hook बनता है. This is known as hook. क्योंकि आप जब stirrup को बांधोगे at the end, there has to be a hook at the end. Then you have how will it support? यहाँ पर तो दो bars के साथ आप इसको stirrup को बांध लोगे. ऊपर किसके साथ बांधोगे? Because ये हवा में तो नहीं रुक सकता ना एक ring. So then you have to provide anchor bars here on the top side. So the purpose of these bars here is they are only meant for anchoring. There is another bar here. Their purpose is anchoring. So you have to provide at least 4 bars for the stirrup to be एक रिंग को खड़ा रखने के लिए There are already 2 bars at least here in the tension zone always. उससे ज़्यादा भी हो सकते हैं, but at the same time then you will also need the anchor bars towards the top. So this is a stirrup. Now there is a limitation as per IS 456 on which I just told you, the minimum area of steel reinforcement. The minimum area of steel reinforcement. What is the minimum area of steel reinforcement? As per IS 456, it is ASV by D is equal to 0.85 by FY. I'll again check from IS 456. Probably this is the formula. Just a minute. Reinforcement that you provide shall not be less than this. AS by BD is 0.85 FY divided by FY. Do not keep this as ASB, this is AST. Force is just AS, but we'll keep it as AST. So what is AST? It's area of steel in tension. We'll again rejoin. We'll have 20 minutes more.